all the esteemed participants. Wishing you a happy Republic Day. Today is our day 3 of our short-term course come faculty development program. Today our esteemed speaker is Professor Prasenjit Dey. So, Dr. Prasenjit Dey received the BTech degree in Computer Science and Engineering from West Bengal University of Technology, Kolkata, India in 2010. And the MTech degree in Computer Science and Engineering from National Institute of Technology, Durgapur, India in 2012. He was an associate innovator with Nivio Technologies, Gurgaon, India in 2012. He was a hardware graphic designer at Intel from 2017 to 2018. He received his PhD degree in Computer Science and Engineering from National Institute of Technology, Durgapur in 2018. He was an assistant professor in Computer Science and Engineering at Coachbihar Government Engineering College, Coachbihar, India. He joined the National Institute of Technology, Rourkela, Odisha, India, as an assistant professor in Department of Computer Science in 2013 and currently working there. His current research interests include artificial neural network, pattern recognitions, machine learning, etc. He has many research publications in internationally reputed journals like IEEE Transaction Systems, Man and the Cybernetics, IEEE Transactions on Artificial Intelligence, IEEE Internet of Things, Journal Impact, Biomedical Signal Processing and Control, etc. He has more than 15 research publications in internationally reputed edited books and international conference proceedings. So very very warm welcome to Professor Prasenjit Dey. Okay, and I am requesting sir kindly share your slides and start the sessions.
Thank you, sir. Thank you for this warm welcome. And thank you all the participants for being present at this auspicious day, Republic Day. So thank you all for still getting the time in the Republic Day for the talk and discussion related to the application of machine learning in agriculture, which is the topic of today in my session. So is my screen okay? Let me share my screen first. Is my screen visible to everyone?
Yes, it is visible.
Okay, thank you. Uh, is it visible?
Yes, it is visible.
Oh. So today we are going to talk about a few applications of machine learning in agriculture. So we try to solve some problems which are related to agriculture that can be solved using machine learning. So it is a kind of hands-on session we can consider. So the yield of agricultural land depend on various factors. Suppose we want to predict the yield of an agricultural land. So this is a problem related to agriculture where based on various factors we need to approximate what could be the possible yield of an agricultural land. First of all, the technological reasoning may be there, like agricultural practice, managerial decisions. These all influence the yield of an agricultural land. Next is biological. There may be different kind of diseases. Maybe there are some seasonal diseases there which affect the crop production. Similarly, the insect, pest, weeds, these also affect the production of agricultural yield. So Due to that reason, maybe technological aspect again come and different herbicide, pesticide, and fertilizer need to be applied to improve the crop yield. So these are again the factors which influence the crop yield. Similarly, there can be environmental issues like climate, annual rainfall, soil fertility, topography, the quality of the water which we are giving to the agricultural land. These all affect the crop yield of any agricultural land. So suppose we want to impose some machine learning concept to predict it, what should be our basic approach? So suppose we are new to ML and we want to apply our ML concept in agricultural field. So what should be the approach? So basically, we can consider the agricultural yield can be a function of various factors. Now, these factors can be technological factors, biological factors, environmental factors, etc. So crop yield prediction can be considered as a regression or function approximation problem. So based on the factor values, we will get the yield value. So it is like a function y is equal to fx, where x is a vector which consists of multiple factors. So the regression problem can be solved by various ML-based regression algorithms. Okay, so ML, many of the parts of ML or concept comes from statistics. So yeah, we can consider the statistical regression technique as well in the ML-based approaches. So linear regression, polynomial regression, multilayer perceptron, KNN, support vector regression, deep and DNN, that means deep learning, different deep learning techniques are there that can be applied to perform this approximation. So I will start with the very basic, the linear regression model. I will demonstrate how it works along with the example. And after that, I may discuss its limitations and why the other ML are required. So what is linear regression? Linear regression is, I hope many of us know about it, but still let us have a let us have a more depth knowledge about it and how basically the analogy of linear regression with the ML code comes that is needed for us for a better judgment of an algorithm and better evaluation or better understanding of the algorithm. So what is the definition of linear regression? Linear regression, as from names, it is clear that it is a linear model. So end of the day, it can do it can draw a line like things which will be a linear come from a linear equation. So linear regression is a linear model, a mathematical model that assume a linear relationship between the input variable and the output variable. Now, output will be one, but input variable can be a vector. That means input variable may contain multiple values, like in the example of agricultural land. So here we can consider in this is below is an example of a linear function like fx. So obviously fx is the output on the basis of the x. Now x can be a vector or a scalar. So suppose x is a vector of n elements or n features. So in that case, it can be function like w1 x1 w2 x2 w3 x3, where w x1 x2 x3 till xn, these are the features, input variables, and based on which we come up with the final output, which is fx. And obviously, w vector, that means w1, w2, w3, these are all these are all the coefficient associated with it. So if we can train a neural network which will be proficient enough to uh, appropriately adjust the value of w or weight vector, in that case we can get a better result. So like I hope every one of us aware that our brain consists of billions of neurons, and all neurons, actually one neuron transmit the information from the current neuron to the next neuron via some axon and dendron. So the dendrite of a particular neuron, basically what it does, it send the information to the next neuron in its axon, and this is how information propagate. So if our neuron connections are strong, that means the weight associated with the neuron is strong. In that case, it can send a very better transmit better information. But if the connection is loose, it may not able to send the information properly. So various neurological diseases happen due to that reason. So similar analogies there in the neural network or linear regression model, which all comes under the category of machine learning techniques. So I will try to slowly discuss how those analogies can be used in here. So here, let us start with a very basic example so that everyone can correlate. So suppose I want to predict the crop yield based on two agricultural factors, which are the total leaf length, that means the length of the leaf, and another is the stem diameter, that means diameter of the plant for which I want to predict the crop yield. So this is obviously a simple assumed explanation or an example. In reality, the factors are not these two, the factors can be many. So throughout this session, I may discuss with minimum two factors like two input variables like total leaf length, TLL and SD. Along with, I may also try to explain the concept with some real life agricultural data where the number of factors may be 10 to 30. And reality, it can be 50, 60 as well. So, but the knowing concept is more important. So, let us, for the beginning, let us consider only two factors which influence the agricultural yield, which is
Not audible. You are not audible.
okay. Can you guide me? Am I not audible?
Now you are, but last
Okay.
probably one or two sentence we couldn't hear. Soon after you said that we will be taking up two parameters for simplicity.
So I would like to request Professor Arnav, if any time any this kind of scenario happens, kindly let me know as early as possible. Will it be okay with sir?
Okay, okay, you are audible now.
Oh, okay. Thank you so much. Thank you. So where was I? Yeah, I was talking about that it is our first step. I am assuming it is our first step to learn or associate ML with agricultural problems. And the problem in our hand is to predict the yield of an agricultural land. And for that purpose, I need to have various input features related to which influences the crop prediction or crop yield prediction. So for the simplicity, I am going to consider two agricultural input features, which is total leaf length TLL and stem diameter SD. So I'm going to consider these two factors, and so obviously the output, that means the F function output F TLL comma SD is this is the output, and this output is basically the crop yield. So crop, as it is a linear regression problem, so output eh, should be a function of linear combination of all the input features. Okay, so let me consider a pointer. So these are all the inputs TLL and SD, and their linear combination will give us a crop yield. This is the scenario. Now, if the input is scalar, like there is only one feature. Suppose total leaf length, TLL, there's only one feature. The output obviously is a scalar, like crop yield, it is going to give you a numeric value that this is a scalar. I hope all of us know the difference between scalar and vector. So scalar will be a numerical value. Then the linear regression model will create a line to perform the regression. Why I'm saying this? So, okay, let me see whether I can use any pen or not. Okay, yeah, I can do that. So if I consider this, that input is one-dimensional vector or a scalar, and output may be a one-dimensional vector and a scalar. So in that case, what this is the scenario. So I can consider this is input X. Sorry for my writing, and this is y output. So obviously, based on some x value, we may have some y value. So if this is the x value, the corresponding y value will be this. If this is my x value, the corresponding y value will be this. If this is my x value, the corresponding y value may be this. And similarly, other points can be there. So obviously, now obviously y is nothing else but, as I have discussed, y is nothing else but the function of x. Now linear regression problem, how it is going to solve the problem? So obviously, if x, which is fx, it is nothing else but a w1 x plus a constant. So I hope we can recall, this is a function of straight line. No? This is a function of straight line if this is x, fx. So this is a function of straight line. So if it needs to approximate, suppose there is some unknown sample. I put an unknown sample. That means that sample has not been used during training. So suppose this is the value x. Suppose this is my x value. I need to know what will be my crop yield based on the, suppose this is the scalar value of total leaf length. And based on that, I need to know what will be its crop yield. So in that case, I may need to get its corresponding y value. That is the corresponding y value. So the output will give me like this. So in that case, basically, this is how we do the approximation. Now, if I use linear regression in this kind of problem, it will try to draw a straight line which may try to fit all the data points. So I have created a straight line. Though it may not be a perfect straight line, but due to my handwriting, but assume that this is a straight line. So obviously linear regression model in this example will try to draw a straight line. So obviously if some x value is there, so if this is the x value, so if this is my x value, corresponding y value will lie in here. So if x is this value, maybe 7, the corresponding y value may be 8 or something. This is how a linear regression model works. But in reality, the things may not be like this, that the relation between the x and y is linear. That I will come to it later. So this is how you can consider a linear regression problem. Now, in the higher dimension, obviously, if instead of 2, if the sample is of 3 dimension, like suppose the y, which is output, maybe depends on 2 factors, maybe z as well as x. Maybe output depends on 2 factors, x and z. The y, here I am assuming y is the output, which is dependent on 2 input features. In that case, the function will look like this, where you can consider the total leaf length may be x and stem diameter may be z. So in that case, as you can see, this is nothing else but the equation of a plane, because this is a 3D surface. Earlier it was 2D surface. This is a 3D surface. And in that case, the thing which is going to help us evaluate, that will be a plane instead of a straight line, because this is 3D. So in high dimension, when we have more than one input feature, the line becomes a plane. And obviously, if I go for much more higher dimension than 3, because if the input feature is 13 or 14, in that case, you can assume the dimension will be n plus 1. So if the number of input feature is 14, then the dimension will be 15 dimension. And in that case, obviously, it will be a hyperplane. So any dimension more than 3, we basically use the concept of hyperplane instead of plane. Okay, so I hope till now the knowledge is clear to everyone. Okay, so now how to measure the performance? So based on evaluation, suppose the actual crop yield should have been suppose 10, but your linear regression model is giving value 9 or something. So the difference between these two is error. Now this error computation is again very important factor in case of ML learning. So if I go back in this example, suppose in reality, okay, let me see whether I can change the color of my pen or not in color. So let me consider blue color. Okay. So basically in reality, this was the X value and corresponding Y value supposed to be in here. So basically the point is in here. The unknown point is in here. So if this is the X value, the corresponding Y value is in here. So this may be value of Y may be here 5. But our linear regression model draw this as a approximated function. So obviously, according to this function, if I feed the value of input X, it is going to give me a value 8. So what is the error? Simple, the error is 8 minus 5. So error will be 3. Now, if multiple, now for this example, error is 3. Let me consider another example. Like suppose, let me consider an example where this is the X value and the corresponding Y value may be, okay, corresponding. Okay, suppose this is the, this is the function. So if this is the X value, our model will give us a Y value like this, where this will interact, so intersect. So this will be the Y value. If this is the X value, according to our model, that should be our Y value. But suppose in reality, Y value lies in here. The point lies in here, which is a unknown point, not used during training. So in that case, the actual Y value is in here, but our model, according to the straight line giving, this will be the Y value. So in this example, suppose the
Hmm. Prasenjit, your voice is some problem.
Y, actually, it may be due to internet issue. Now I am clearly audible.
Yes, yes, you are audible.
Okay, in that case, I can do one thing as there may be some internet problem. So let me turn off my video. So in that case, it may somehow help to increase the network bandwidth. Now, am I clearly audible?
Yes, yes, you are audible.
Oh, if the problem persists, then I will join maybe from other machine or my internet. Okay, thank you for letting me know. So now in the second example, so this was the sample one. In that case, for sample one, the error one was 8 is the predicted value and 5 was the real value. So error was positive 3. Now for the second example, if I want to consider the example 2, so corresponding error, if I want to predict, then error will be E2, which now the predicted value is what? The predicted value is 3 in this example. So if the next sample is in here, so X value is this and my predicted Y value is 3. So 3 is the predicted value, but in reality, the sample lies in here. So if this is the X value, the corresponding Y value should be 6. So in that case, 6. So in the next example, error is -3. So I would like to ask the participant, if I want, based on this sample 1 and sample 2, if I need to evaluate the error of this model, what will be the total error of this model? Because if I want to add the total error like ET, the total error of the model, and it will be what? It will be 3 minus 3, and total error of the model will be 0. So if I want to check, actually, like, we evaluate on an overall basis, not on the basis of an individual sample. So overall, this network has no error. If I want to add the error like this, up to this, is it clear to the participant? I would like to know, and I also would like to know that can anyone suggest any idea that how to actually get the error? Because this is how, if we try to add up the error, then the model can mislead us. As we can see clearly, for each sample there is an error in the model. However, if we add all the error, then overall the network do not have any error, because all the positive and negative error are basically cancelling each other. So can anybody from the participant in a chat box write that how to deal with this kind of error?
We may square them.
Yeah, add square of the error. Exactly, that is what I needed to know. So if I want to go back, then then in this example, so we have various mechanism to do that. First of all, the mean absolute error. Mean absolute error, that instead of considering plus 3 minus 3, it is better to take a mod of it. Mod of it. So obviously it will add 3 plus 3, 6. So overall error will keep on adding. So mean absolute error is a one metric used for any regression model, the error analysis. Next one is, as it is stated, that mean squared error. So take the difference and square them. So based on the earlier example, it will be 3 square plus minus 3 square. So it will be 9 plus 9, 18. So it is again okay. So error is adding. Third is root mean square error. Now in the earlier example, what was the problem? Earlier example, it was like it is increasing the multitude of the error. So error is not that much, but it is increasing the multitude of the error. So it is not, so the error is actually 6, but it is showing 18, which is not desirable. So many of the time, root mean squared error are preferred. So it is square root of the MSC, convert the unit back to its original unit of the output variable. So you are just adding a square root before the MAC. So it is root mean square error. And majorly nowadays, this is the metric used to evaluate the performance of any regression model. It is the indicator of a goodness of a fit of a model. So if the value of R score is 1, that means the model is perfectly predicting the function. And if it is 0, that means it is performing worst in predicting. So R score is a very important metric to evaluate any regression model. And R score can be evaluated like this: R2 score, sorry, or R square score. Actually, you should say R square score. So R square score is basically a numeric function which is 1 minus sum of squared regression error divided by sum of squared error. So it is, I hope, known to every participant that how to compute the R score. But still, if someone having any doubt related to how to compute R score, then I can provide one example. So, okay. So suppose I am having 3 sample. One sample is there having value 3, and model predicted the value maybe 2. Another sample is there maybe value 6. Model predicted a value 7. And another model, suppose consider the actual value is 9 and model predicted the value 9. Very good. So this is the real value. This is the predicted value. Now what will be the error with respect to the first sample? The error is 1. For the second sample, the error is 1. And for the third sample, the error is 0. So basically, this is the error generated for these three samples. Now, let me compute the mean value of it. Mean of these three samples is what? 3 plus 6 plus 9. The mean will be 6. Now, if I take the difference of mean from the output we obtain, so basically 6 is the mean. So 6 minus 2 will be 4. Then this will be the 7 minus 6, it will be 1. And 9 minus 6, it will be 3. So this is the basically this is our what? This is basically your model overall fit of the model. That is the sum of square of total error. This is basically represent the sum of square of total error, and this represent the sum of square of regression model error. So actually you need to do the square. So 1 square plus 1 square plus 0 square, which will give us a value 2. And divided by, it will be 4 square is 16, 1 square is 1. So 16 plus 1, 17, and 3 square is 9. So 17 plus 9 is 26. So as we can see, it will have a value close to 0. It is going to have a value close to 0. So R square score is doing what? It is doing 1. It will do 1 minus 2 by 26 or 1 by 13. So obviously we can know that it will be approximately the value will be 1. So we can conclude that our model is performing quite good. Now, if I consider some other sample where this value is close to 1, in that case, the value will keep on going closer to 0, and we can say our model is performing bad. So I hope the R square metric is clear to everyone, because many of the time we use R square score, but we having difficulty analyzing the interpretation of the result. So it may help you to understand or interpret the result. Now I am quickly jumping into my code and showing you or demonstrating you how in reality you can implement the code. So this is the code. Okay, I need to go back to my present. I need to turn it off. Okay. Now I'm moving into my code segment. I am now going to demonstrate how to implement the linear regression model in Google Colab. So if Google Colab is not familiar to everyone, I suggest everyone to use it at least in a basic understanding purpose. After that, if you are having a server, you can run your code, because Google Colab in free version, there are many limitations. But for the beginners, for learning basic ML things, it is quite helpful. So you need to write Google Colab in a Google any browser, and after that a window will open where you can create a new notebook where you can write your program from the beginning on your own, or if you have any existing code available in a computer, so you can upload that code. So you can upload any existing code available in the internet, sorry, in your computer, or you can open any code written by you earlier. You can also open the code, like linear regression code is written by me maybe in 2021. So I am going to demonstrate that code, and if you want to create your own code, then you can write your code. You can generate your code also. Google also helping you to generate your own code. So nowadays coding is not so difficult. Now leave. So I want to do the prediction. Now this is import pandas PD. I hope many of us are familiar with Python language, but if you are not known, I would like to say that this is a data frame. Like, for us to understand every data is very easy if they are in the form, like there will be a column header, there will be a column header, and there will be number of rows, and each from this table we can understand what will be the value. So for the first sample, this is the total leaf length value, this is the stem diameter value, and this is their corresponding output profit. So if the data is in this tabular form, it is easier for us to interpret, and due to that reason, we use pandas data frame. This is a library provided by Python. Now I want to let me show you on which data I want to evaluate my model. So not this data. I am going. Oh, okay, this comment. I am going to show you the performance on
Still,
two
your
data. One.
slide is visible, no other screen.
Okay. Sorry for that. Sorry for that. So let me see how I can do that. Hmm. Let me see how we do that. Stop sharing. Now it should be clearly okay. So can you see my Mozilla browser?
Yes.
Okay. So I was talking about this code. So this is a code for linear regression, and I used to share this code with every participant so that they can learn by their own. So okay, I think I have given the permission to load. Let me see. Yeah, I have given anyone with this link can view my code, copy my code, and work on their own. So I am copying it now. I am putting in the chat box so that you people can run along with me. So you people can, in the run time, you can simultaneously do a practice. I am sharing the code with everyone. And in the meantime, let me demonstrate the code. So the data I have stored in GitHub. So GitHub, the data, raw data is stored in like this only. So here you can see, let me zoom it. So you can see there is a two input feature, total leaf length and stem diameter, and yield is the crop yield value. This is the my data set. So all input output combination are there available. This is my raw data. So I am importing the data in the data frame. So after writing this line, if I want to see the all my data, then I can do so. See, I have created a data, and the shape, there is a number of sample is 50, and each sample has 3 dimensions. And as you can see, this is the values. So first two column is input, and third column is the output column. And these are the 50. First is the column header, and sorry, it is starting from Python. Everything start from 0, like C languages. So there is a 50 sample. Okay, I have taken the data. Now, let me try to explain this. Now, I need to separate the data between the feature and the output. As we know that among these three columns, the first two columns will act as input feature, and the last column will act as label or output. So we need to basically split the data into a input data and the output values. How I can do that? So basically I am creating a list which contain the column header name TLL and SD, because these two columns will act as the input features. So input features. And after that, I am considering only these two columns, and obviously what was the name of this table? The name of this table was data, because I am storing the data in the data table. So data is the variable where I'm storing the data, and after that I am giving the column name these two. So obviously X, that is my input feature, that will contain all the rows and only these two columns. This column will not get selected because I have discarded this. And similarly, when y is my output, so x is the input. X is input. X is the input feature. And where y is the output value. Here you can predict the output. Now, obviously, for the better understanding, I have written that, okay, so data, and inside this, if we provide the column name, it is going to extract the value from that particular column only. This is the feature available in the Python language. So here you can, Y will contain all the output values, as you can see, and X is going to contain all the input values. For better understanding this print head, I should have modified that these are X values. The code is shared with you all, so you, the real participant, you can also check this code and run according to your wish as well. Let me run it. So as we can see, the X values, these are the X values and these are the Y values. Is it clear? Clear to everyone? Okay, let me put a new line. It will help you to understand it more clearly. Okay. So you can see this is the X table and this is the Y table. So we have successfully split the data into the training input sample and the output level. Now this is where I am going to apply the linear regression model. So this is how you can use sklearn. Sklearn is a library which we also known as scikit-learn library. You can use the scikit-learn library, and many of the machine learning functions are available in this library. So from sklearn.linear regression model, we want to import linear regression because our current job is to evaluate the crop yield by using linear regression model. So I am going to use linear regression, and from sklearn, I also need to, okay, so when we evaluate a model, so like in an exam, if we test the math in the whatever math problem we solve in the classroom, if the same math problem is given in the exam, it is quite natural that every student will be able to answer it, unless a student who has not attended any class or maybe not so attentive. But obviously the problem explained in the classroom, if the same problem is given to you in the final exam, then expected that you will be able to answer all the questions because the questions are already known to you. So this is called the training data in machine learning concept. So obviously we in the exam time, to know whether they have understood the concept behind the math or not, we should give a different problem in the final exam, which was not taught in the class, but the concept has been demonstrated in the class. So similarly, to evaluate how good a neural network is, for that purpose, we need to break the data into a training data and the test data. Training data is used to train the model. So obviously, our human, like a child, that child do not know anything when he or she born, but as from the nature or parents and all who nurture them, they keep on they undergo the training and they learn the good and bad things. So and after that, when the real situation comes, they act upon it. So similarly, in the case of neural like biological neuron of a child, the artificial neural network also works like that, or any machine learning algorithm also works like that. So basically, we split the data on the training data and the test data. Training data precisely used for training the model, whereas the test data actually used to evaluate the quality of the model, how good the model is, or how generalized the model is. So for that purpose, I have used this train test split. This is again available in the scikit-learn library. And in this example, I can import any data set. Keras library, the scikit-learn library also provide multiple data sets. which is already stored in there. But currently in this example, we have not any such data set, so we can delete it. And after that linear model, the linear model I have imported, you can ignore it because it is again not maybe required. Now let me run the code. So I am going to import the from scikit-learn dot linear model. I am going to import linear regression because I need to perform linear regression. After that, I am splitting the total 50 number of samples was there. Among them, I need to split some for training and some for testing. Like if I have 10 problem, I will discuss 8 problem in the classroom and give rest of the 2 problem in the final exam to evaluate how much concept they have built. So what this line is doing, the train test split, this is the input feature X. As we can see, this is the input feature. Y is the output values and test size. So how much percentage of the data will be used for testing and how much percentage of the data will be used for training, that basically decided in here. So if I write 0.10, that means 10% of the data will be used for testing and rest of the 90% of the data used for training. If I change it to 15, in that case 15% of the data will be used for testing and other 85% of the data will be used for training. And random state one means every time the model will start training with a new input with a different seed value or initial situation. So as we can see, we have split the data into training data, training level, and test data, test level. So basically, this is training data, this is training data, this is training level, this test data, this test level. Because X represent the data or input feature, where Y represent the output value or output level. Now, after that, like any object-oriented programming language, we need to, for any function, we need to create an object of it. For any class, we need to create an object of it. So for linear regression model, I am creating an object and naming it linear regression. You can give any name you wish to give. So I have given the name linear regression, lean regression. This is the object created by me, and after that I am using this object and I am applying. So this fit function is available in this class linear regression. So I am using the fit function, and in the fit function I am passing the training data as well as uh, uh, means training input as well as training output. Like in the class, we do not give only the input or problem to the class, we also solve the problem in the class. So I am providing the input as well as the corresponding output also I am providing. So from this training data, the network will learn. So fit function will help the network or linear regression model to learn what is the underlying concept behind it. So let me train it. Training is done. After the training, I need to evaluate the performance of the model. So from scalar, you can import the matrix library. In matrix library, there are multiple functions are there which will do the mean absolute error, mean square error, root mean square error, r square error. All are there in the matrix. You do not need to manually compute the value. You just call the corresponding function and it will do the job for you. So, and this is used for NumPy. NumPy is a library. NumPy is a package. NumPy library is used to compute any matrix related, tensor related job. So NumPy is a library used for numeric computation. And that is why, so basically any number computation you can do, precisely the data should be vector, matrix or tensor form. And this is actually your model, like giving the real test, the final exam, where the input was not known to me, but we are predicting the output. So X test is the test input, which was not used during training. So linear regression dot predict. From this linear regression, lean rig, this is the object. I am calling this predict function, passing the test sample, and the model will predict certain values. So predict is the predicted value. So y predict is the predicted value. And what was, so basically this is a zip function. Basically it will do what now? It will basically put them parallelly, line by line. So one column will have the predicted value, which is obtained from linear regression, and y test is, if we consider y test is the real output value. So y test is the real output value. So now I am basically clubbing them. By zipping means clubbing them. One column will contain the predicted value, the next column will contain the actual value. And the difference between these two, basically the error amount. So as you can see, I have done it in here manually for explaining purpose, that you can do it manually, you can do it by using the function available in a matrix. So here, as you can see, I have done it manually. So the MP is the predicted value, AB is the what? AB is the actual value. So I am taking the absolute difference between these two, and after that I want to have the value till 2 decimal position. That is why I have used a round function and put comma 2. So every value will be up to 2 decimal position. Else it will be up to 8 decimal position, which is done by default in Python language. So as you can see, the model predicted value is this one and actual value is this one, and error is the absolute difference between these two. This is how you can evaluate a model. And after that, so this is only for the understanding purpose I have used this, but in reality when we do the real professional coding, we do not get time to write all these intricacies. Rather we put like metric dot mean absolute error, send the predicted value and the actual value, it give me the uh, error value. And again, if you apply the absolute function, it is going to give a value up to maybe 2 position or 3 position defined by you. And metric dot mean square error, this is the mean square error, which is quite in amplitude because of square function. So it is preferred to use root mean square, where it again applied a root over this. So it is going to give you this error. And R2 score, R square score is also very low. So it is not so good. As I have told you earlier, that if it is 1, it is quite good. If it is close to 0, it is bad. So from this understanding, we can understand that linear regression model may not be a very good enough. You can also perform some cross validation. Okay, if I get time, I'll talk about this cross validation. And okay, so this is how you can do the job. Up to this, I hope it is clear. Now I want to quickly switch into the real life problem. Like this data was synthetic data, which was simple, but in reality, the data can be like this. And if you look into this data, that it is depends on multiple factors. So how many factors are influencing the output? This is the new data, the real life data on which I now going to evaluate our model. So moisture 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 input features are there, and one outcome is the final output. Maybe you can consider crop it. So this is the data. Obviously, the first thing, what let me explain the code line by line. So in this example, I am going to use the linear regression. So this is the object created for linear regression. Feed the data x and y. Okay, so for in this example, it may not be required now because I am going to change the data. So you can consider these three functions I have talked about earlier. Linear regression is used for using any function related to linear regression. Train test split. It will split the data into training data and the test data, and these are again not required. Now in this case, I am going to. This is comment. So this is I am not using now. This comment. This is the data. So which data it is? Yeah, this is the real data. I'm not going to now I'm going to work with. So the input feature, this column will act as input features. Obviously, this is not I'm going to consider. And obviously the value with respect to this column only I need to fetch. So this feature value will be fetched from the input data, and that will be put into the input data table, or I can consider input data matrix. And so X will contain all these new input data, and outcome is the column which is having the output values. So obviously it is the label. So X is the input features, input feature matrix, and what is Y? Y is the output. Output is always scalar, na? So output will be scalar. So now this is the training of the model. This is the object of linear regression. Fit model is used for training, and while training, we need to provide the input as well as output. Else, how somebody will learn? So this is the training. After training, this is the prediction. Linear regression predict, and while we are predicting, in this example, for simplicity, we have given the same data. So this is prediction. And after that, we want to evaluate the mean absolute error, mean squared error, root mean squared error, and R square square. This, let me run this code. Okay, so from code we can see it is the input, and this is the output. And as we have used the same data for training and testing, for simplicity or quicker computation, we can see the R score is 1. That means for all the training data, the output, the prediction is perfectly matching with it. So till now, is there any question related to the understanding of linear regression or how to write a code of it? I will
What
jump
is the
into.
outcome 1 and 0 representative of?
Okay, okay. Let me go to the. Uh, you are asking about this.
Yeah.
Yeah.
When the
So
outcome is
basic.
1 and outcome is 0, how do we interpret it?
Yeah, basically, in this particular data set, what they have done. So basically, based on these features value, the crop yield will be 1, and if for some other combination of this feature value, the crop yield will be 0. So here in this example, it is the corresponding output value. So for this combination, the crop yield will be 0. For this combination, the crop yield will be 1. Okay. If you want to change this value, you can change it. So in that case, I need to go to my GitHub and change this value. So you can also play with it. You can create a data like this, and as you can see, this is CSV file, and accordingly you can change certain values. From this one value, you can change it to 0.9. This 0 value, you can change it to 0.1, and accordingly the model will behave. This is just output value. Any output value, if you want to consider, you can consider. It is not like it will be 1 and 0 only. It can be any real life value. Like in this example,
No, but this is an
you can see.
output parameter, I believe, which would be indicating whether there will be crop yield or not. Am I right? Or what is it
Sorry,
actually?
sorry,
The
sorry,
physical
I didn't get.
interpretation of this data.
I didn't get you. Can you clearly state the problem?
I am asking what is the physical interpretation of the outcome parameter being computed as 1 and 0? What is it indicative of?
It is indicating the crop yield. Based on feature, what will be the yield of that agricultural land? It can be any real value. Suppose you are a scientist, you are a researcher, and a data is provided to you. So these are the parameter available. Now tell me what will be the yield of this agricultural land.
Can
Should
we
I
say
should
that this regression model is providing me with two partition regions, and based on the data, I will have yield either in region 1 or region 2, maybe the two regions being identified as 0 and 1. where one indicates a good crop yield and the other indicates a bad crop yield?
No.
No.
The example I am not talking about it. The problem you are talking about, that is a classification problem for
Okay.
which we use logistic regression. That two region is there, and I need to decide that according to the parameter, it will be a barren area or a fertile area. So that is the classification problem. So basically, this, as I am assuming, the output values are misleading you. So if these kind of things happen, then consider this example. As you can see, this is the input value and this is the corresponding output value. So in case of regression, the output value is always a real value. Am I clear?
Okay.
Are you confident that it is clear to you?
Not much.
Okay, do you have the basic idea of what is classification problem and what is regression problem?
Regression is actually we are predicting a future value here.
No.
No.
Regression means you are predicting a value, but the range is the prediction should be within range. And forecasting for if you want to predict the future value, that is not called the function approximation. That is called the forecasting, and forecasting
Okay.
comes under forecasting is quite difficult.
Okay.
Let me explain you with an example. If I get, I think I can access. Okay, give me a minute. I hope I can access Notepad and all. So I may not get too much time to it. So discard. Give me a
Sir,
time. Okay, 1 minute. Let me explain what is the difference between forecasting and prediction. So basically, these are the values, and these may be their corresponding. This may be their corresponding output. So based on this input, so these are the label, and this is their corresponding values. And let me put it here 7. So this is the input, and this is the corresponding output. Now, obviously, there is a number which is 5. 5 is within this range, and I may ask if the value of x for x equal to 5, what will be the value of y? So x is within the range. It is called interpolation, and for that purpose we use regression. And the problem which I am talking about is regression, and the problem which you want to interpret, that is prediction. Like up to 7 I am having a value. Now if you ask if the value of x is 100, if you ask the value of x is 100 and what will be the value of y, so you are checking outside range. So in that case, the problem is called future prediction, which is forecasting. So they are quite
Okay.
different.
Fine.
So
It is clear now.
the
Yeah.
regression model may not work well on future prediction. It's not supposed to work well.
Okay. Thank you.
Any other query? Any other query? Okay, then shall I proceed?
yes, sir.
Okay, thank you. So as you can see, we are not satisfied with the value of linear regression. Linear regression is giving me quite bad value, in fact. So as we can see, the R score was what? R square is 0.43. And this and the next data set, the bigger data set, the value of R score was again, I guess not. So okay, I have tried with only training data. So you can split the data into training data and test data, and you can do the checking. So okay, for the time being, I think I also can do that for you. Hmm. Okay, where was it? That was the splitting done. Okay, there is the split. Hmm. So strain will be used for training, and Now I am using a different set of data for training and different set of data for testing. Suppose I want to use 5% data for testing. And obviously in that case, the prediction will be done on the test data, not on all data. Okay, let me run the code. The internet is little slow over here. Okay, so yeah, y predict I cannot use y, I should have used y test. Okay, see, still our score is quite good, close to 1, because this value is again not so realistic. So this is how you can do the play with the code, and as you can see on the runtime, you can do certain changes to the code and check how it is performing. Like if I want to change this train data, test data, then in that case the performance may change. So like if I use 0.10% of the data if I want to do for testing, see how it is working. Okay. So, okay, oh, sorry, I have refreshed it, so it again comes back to the previous value. So these changes are basically not saved. See, it is still giving a quite a good value. Okay, so let me quickly jump into the other advanced models. So linear regression I have talked about, and now linear regression is not going to give us a great result. So we need to jump into the polynomial regression. Polynomial regression means this is the scenario. Let me come to this point. So assume a model a polynomial relation between, because in reality the relationship are not linear. So relationship are polynomial. So a model assume a polynomial relation between the input variable x and the output variable y, where input variable x obviously can be one-dimensional vector of cardinality n, where n is greater than 1. You can see this example. In this example, the first example I have considered polynomial with degree 1 and number of input feature is also 1. There is only one input feature x1 and the degree of the polynomial is again 1. So it is like a linear regression. It is nothing else but the linear regression. In the second example, I have considered the degree 2 and the input feature is 1. So I am going to consider x1 with degree 0 as a, sorry, degree 1, x1 with degree 0, which will be 1, and x1 with degree 2. Now, if I consider polynomial with degree 2 and number of input feature as well as 2, so there will be two feature x1 and x2, where I am considering all the degrees of x1. I am considering degree 0, degree 1, degree 2, and for x2 also I am considering degree 0, degree 1, and degree 2. And obviously all the combination of all the features will be there. So you can understand how complex it will become if I want to make a generic equation. So if I want to consider only one input feature and the degree of the polynomial is n, then I need to consider x1 to the power 0, x1 to the power 1 till x1 to the power n. And if I want to consider a polynomial n with two input features, so obviously it will be w0, x1, x1 square, x1 cube, like that. I will go till xn. And after that, for x2 also it will go from x2 square till x2n, and finally all the combination of x1 and x2 will be considered. So as we can see, the equation is quite complex because it is a nonlinear equation, and they may be quite better and better in judging the performance or judging the model or evaluating the model. So in our example, for simple example, we had considered total leaf length and stem diameter. So there is two features, and here in this example, I have considered this scenario, like number of input feature is 2 and the degree of the polynomial is also 2. So degree of the polynomial 2 and number of input feature is 2. So we have considered for total leaf length, I have considered the 0 degree, 1 degree, 2 degree. For stem diameter, I have considered 0 degree, 1 degree, 2 degree, and the combination of these two. I hope what polynomial regression is clear to everyone. Now let me try to solve this with a real life problem. So I hope I'm having a code for that one also. Okay, so open my code and the code for polynomial regression. Polynomial regression, we need to evaluate whether it is better than the earlier one or not. So linear regression is done. I'm closing it. Leave. Polynomial regression, the code is there. I think I used to share my code. So this is the copy. So you people can play with this code. Let me share this code in chat box. So this is the code which you will going to work with polynomial regression. Now in this example, it may be quite interesting that matplotlib, okay, matplotlib.pyplot, and you can rename it as PLT. It is used for visualization purpose in Python language. Used for visualization purpose, Python. It is used for visualization purpose in Python, and after that pandas we have talked about. We end of the day all the numerical data we wish to store in a tabular form to easy access. Because if I know the row, if I know the column, I can easily access the data. So that is why pandas are very people are addicted to use pandas. So, okay, I have fetched the data, and this is the data, the same data, not this one, this data which I am going to use, because explaining with this sample data will clear the concept. Okay, now I have taken the data, and after taking the data, I have done the training, splitting between the input feature and the output level. I think up to this part, things are clear to everyone. Okay, one second, huh? So, okay, then this is how we can see the input and output. And after that, let me talk about the polynomial regression. How we can implement a polynomial regression code in a neural network. Sorry, in a email. So, sklearn dot preprocessing import polynomial features. So by this you can import the polynomial features. Polynomial features means degree. If degree is 1 and number of feature is n, it is quite similar like linear regression. So polynomial features means we are imposing the concept of okay, after polynomial, as I'm talking maybe too many complex things now. So after discussing the polynomial regression, I may take a break. And after that, I will talk about maybe a CNN and another neural network, if possible, if time permit. So basically, from sklearn pre-processing, import polynomial features, and sklearn.pipeline, import make pipeline. These two basically libraries which will help me to basically create the architecture of the polynomial model. So as you can see, polynomial, what this pipeline is doing, it is imposing the polynomial features, and polynomial features is calling the linear features. So basically for each degree, I am going to evoke basically linear model. And here in this example, I have considered the degree 2 of the polynomial, as I have stated in this example that I am going to consider this. In this example, I have considered that I will going to consider a polynomial with degree 2. So for the better understanding, I have used degree 2, and I have split the data into training data, test data. 20% of the data will be used for testing. This is how you can call a polynomial regression model. So basically, I am creating an object polynomial regression where I am calling the function.
Sir, you are not audible.
Hello, please confirm other participant. Am I audible or not?
Now it's okay, sir.
Okay. It may be due to the fact the internet issue, due to the weather in here, maybe internet delay is there. Uh, that may be the reason. That is why I turn off the camera as well. Uh, okay, yeah, please try to adjust. Okay. Now what I need to do, this is how you can call. So polynomial regression, it is what? It is an object I am creating by using the function make pipeline, and in which I am say passing two parameters. First of the degree of the polynomial, which is polynomial features, and another one is the linear regression model, because inside for each degree it is going to evoke a linear regression model. And after that, this is the training of the polynomial regression model. Okay, the training is done. After that, these metrics are already known to you, so I am predicting the value by using polynomial regression, and as you can see, the prediction is quite close. It is quite close. And if I want to evaluate based on the metric used by scientists of ML, and you can see R square score is quite high, zero point 0.9. That is quite good. So from there we can know the polynomial regression is much more better, because in reality the output curvature may not be the ideal straight line, and it's not supposed to be the ideal where you was talking about that. Okay. Let me quickly jump into there. Okay, it is not safe. So basically, in reality, what I one needed to say is that suppose reality, the features are like this. So a straight line may not be a good to regress it. Rather than it should be considered a curve fitting problem, which should go through every point. In that case, if a new sample will come, like this sample X comes, so obviously model can quickly predict that, yeah, it will be the corresponding Y value based on this X value. Obviously, this curve may not be good enough, so curve can be this one. So in that case, you can see it can easily predict the value correct way. So obviously, a curve is better to predict. A curve function is better. Obviously, it is a nonlinear function and better for predicting any function or approximating any function. So till now I have discussed this part. So I would like to take a 10 minutes of break, and after that I will quickly talk about another neural network and maybe with another example. And after that, if time permits, I will talk about another DNN model. Thank you all.
Thank you. So after a few minutes, again we will start the next sessions.